Let us see a new data structure which are sets, and then how it is implemented. Maybe I should introduce hash functions before sets, but I thought I will introduce what are sets, and then we'll talk about why we need to discuss about hash functions. I'm sure you might have studied in your data structure program courses. So the focus of this session is going to be this school. In your school you might have studied set theory, and then we will talk about the features of sets implemented in Python, and then how hashing helps in implementing sets. Then it also helps in having a implementation of dictionary also. We will cover it later. Okay, so far what we have seen, strings we have seen, and list. Now list is a collection or a container. Okay, we call it as a container. It can key, it can have any number of any kind of objects in the list, and we can iterate over them. It's ordered and mutable. We can modify it. So these are the properties we saw about lists. Now we are going to learn about sets. Before that, I will introduce you to set theory, and then we will see how does the set differ from list. Now in mathematics, a set is a well-defined collection of distinct objects, set of polygons. We call them as a set because they all, maybe somehow they are related. The relationship need not be in terms of their types. It could be based on the application. Like you can have an employee data as a set, but the employee data may have different data types: name, address, age. They are all different types, maybe salary, but they are all in a set because they are related in some way, because it's talking about a particular employee's data. So similarly, set is having a collection of data which are related normally. That doesn't mean that they are of the same type. They can be of different types. The arrangement or order of the objects in the set does not matter. It is like you keep it in them and then you uniquely take out, but there is no order maintained inside them. Okay, when it is maintained inside the set, it's no, it's not ordered. A set may be denoted by this. I will talk about the flower bracket. Okay, this is common for even dictionary also. Now, how does the compiler differentiate whether you are having a set or a dictionary? If you have a set of elements like this, it is a set. But if you are having a key value pairs, okay, key value, then it is a dictionary. That means you are having a key which refers to a value. So we use the flower bracket for both sets as well as for dictionary, which this dictionary we will cover later, maybe in the next class. But Python uses the same syntax for both. Like list, it uses square bracket. It uses this for sets if they are separated by one element, not a element followed by a colon, and that having multiple entries, then they are dictionaries. Okay, that's how the compiler of Python differentiates between whether you are trying to define a dictionary or a set. Okay, now I forgot about tuple. I think we saw tuple also already. So sorry, tuple, list we have seen to both. Tuple is, let me talk about tuples. we said that it is to be covered by parenthesis and then a comma b comma c. Actually here the parenthesis is optional. Even if you say ABC, it means that it's a tuple. Okay, that's why when a function, you have a function something and then it returns a comma b comma c. So you can give any number of objects and then list them out, or not. When I mean by list means it is, I'm not talking about this list. List of items separated by comma means that it's a tuple. Okay, you could do this, otherwise it assumes that it is a tuple, and then this function returns a tuple object constructed with these values, and you get the, when you assign it to the, when you are calling this function, you may assign it to either like this or you may do this. Both are same, both are acceptable. Or you can just say that it's a tuple object, then it will be pointing to the object which is a tuple. So remember that you can individually assign them, which is unpacking. Okay, you can unpack it and then assign it to individual variables, or you could have a one single tuple object which is pointing at this object which is coming from the function. So tuple is a list of variable items which are separated by commas. Okay, that's what we learned last class. So here we are going to see sets. I don't know whether there is some sound, so let me check whether I am still connected to you. Okay.
Yes, sir, you are connected.
Okay, fine. Thank you. I can't tell you that. Please let me know when I am not connected. It is like those who are absent, please say raise your hands. So I need to come myself and see whether I am still talking to myself or talking to you. Okay. So far I hope things are clear. Now you know what I am going to show you. Very good. So universal set A, B, two sets, A union B covers all the elements in them. A intersection B and A difference B, A minus B. The color shaded area is what means what I am saying here. Elements in A but not in B. Here elements in B, not in A. Difference of B minus A. So A minus B and B minus A are different if the sets are different. And this is something symmetric difference between A and B. Elements in either A or B but not both. So here we are referring to the elements which are shaded. So elements which are in A or B but not in both. Okay, this intersection is removed. So universal minus U minus A intersection B is what is a symmetric difference. So since sets data structure is based on the set theory, so all these operations can be performed using some symbols as well as library functions. So we will see today with library functions how to do this. Okay. Now what are the features? Set is a collection, as I mentioned, unordered. There is no ordering maintained within the sets. The set itself is mutable, iterable, and unindexed. Okay. That means if it is not ordered, you cannot index them. So it's unindexed. So set has a non-duplicate members which are immutable objects. Now it is a non-duplicate. One more important thing about set is you cannot have a duplicate element. So that's not allowed. It doesn't allow duplicate elements, but it doesn't maintain any order, but it makes sure that there is no duplicate maintained within the set. Now the question is, how does it go through it? We will see it, that's where hash function comes. How, when you are iterating over the list or when you are trying to fetch one item from the list, set, how is it accessing a particular element, whether it is present or not? So that is, it uses a hash function for that. We will see that. So they are non-duplicate elements, but they are immutable objects. So they themselves cannot be changed. Okay. So let me tell you, before we discuss about sets in detail, the difference between dictionary and set. So I said that A, B, C, a list of some sequence of elements which are not ordered, is a set. And we use a flower bracket for both dictionary as well as sets. Now dictionary will have maybe A is a key and val 1, and then B colon val 2, then C colon val 3. Now this A, B, C, which are called keys, and this is value, and every element in a dictionary is a key value pair separated by colon. Now what is the uniqueness of key? Key has to be immutable. Value can be mutable in a dictionary. Okay. Now we can derive a set from a dictionary by knocking off the values. If you are picking up only the keys from a dictionary, it becomes a set. Okay. That means what? These elements which are immutable are given here. That's why I said that it's a immutable objects. What you have in sets is immutable object. That means they cannot be modified. Now then you will know that you cannot have a list as a key, because the list is a mutable object. Now can I have a string as a key? Yes, you can, because string is not mutable. So you can have a string as a key but not as a list. Now I told you that in a dictionary we knock off the values which are mutable and then take out only the keys which are immutable, then we get a sets. And these sets are nothing but a sequence of unordered immutable objects. Now why is there need that we want the sets to have immutable objects? Now let us see that. It depends on how a set, I'll call it as a set, my set, how this set is maintained or managed inside the library and how it is accessed. Because when you want to look for a particular value, you will be looking for that, and then it will give you, okay, that whether it is there or not, and if it is there it will give you. Now when it is searching through this, it uses a hash function. Okay, I will talk about the hash soon. For this hash function, you can call it as a function which is returning an index. Okay, it returns an index which will help this library to access a particular element. Suppose you are looking for a C, I pass a C to the hash function, it returns me an index 3, then I will go and see the third element should be this. Okay, it is somehow maintained like, I use this hash function to know whether the particular element is there, and if it is there, what is the where exactly it is inside the set. Now this hash function is computed for a given object in some mains. How is it done? It is done by looking at the content of this immutable object. Suppose if you are giving a string name, and then this is another string ABCD. Since they are immutable and they are different, they are not duplicate, certainly you will have different objects with the values, different values. So the hash function, when it is given to it these different values, it will return different indices which can be used for accessing the element inside. So we will come to that soon. The reason that we don't want these objects which are there in the set to be immutable, because we want to have the hash function returning the same index every time I access it after it has been added to a set. So I don't want that to compute something else. So we are going to be very strict about having only immutable objects within a set. Now, I may have a different object. As I said that it could be any kind of object, different object, but if you see that they're all immutable, tuple is immutable, you know, my string, and then any float value or integer values are immutable objects. So they can be formed as a set. So set allows tuples. Now it allows tuples only if they contain immutable objects, because you saw that a tuple itself can have mutable objects also, but set allows a tuple only if it contains a sequence of some immutable objects. Now why is it so? Because it is going to compute based on the contents of the object, and then the hash function is going to return some index. If this is changing, then its contents will be different and the hash function will return something else. So every time when I am iterating over it and looking for this particular object in the set, I may not be able to locate it because there is no ordering maintained. The index is computed based on the contents of those objects. So I want those objects to be immutable. So tuple as such may allow the objects to be changed. So because what it is pointing at could be changed, which I mentioned it in the last class. So we need to have a tuple only which are having immutable objects so that we can compute the index using the hash function. Then it can be indexed into the set. So that's the reason set allows tuples only if they contain immutable objects. You know that tuple themselves are immutable, but it allows mutable objects, which I told you earlier. So tuple has the flexibility to have mutable objects, but such tuples cannot be a member of a set. That's all. That's the only limitation. You can have a set only with having tuple if it has only immutable objects in them. Okay. I told you the reason also. Here, sets themselves are immutable. Okay, it's a reverse of the tuple. Sets you can keep adding more elements. Okay, sets is mutable. I said set is mutable, but the objects that they are there having are immutable. So sets themselves are mutable. It allows only immutable objects, whereas tuple themselves are immutable, but it allows mutable objects. Okay, it allows both immutable as well as immutable object. Here only immutable objects. Please find the difference between them. Okay, tuples, they are themselves immutable, but it allows both mutable and immutable objects, whereas set are mutable themselves, but they don't allow mutable objects in them. Okay, the reason being computation of hash function index. So sets provide methods for constructing and manipulating unordered collection of unique elements. Now, I mentioned that you cannot have duplicate, okay, non-duplicate members. So unique elements, every element in the set is unique. I cannot have one more number 2, one more 3.14, because it may be converted into a floating point representation, but still these values, the string is same, so it will not allow you to have immutable, same content, unique. It needs to be unique. Now, what are the uses of sets? Membership testing, different uses of sets. You can test whether a particular member is part of a set or not. Removing duplicate from a sequence. Suppose if you want to, you are getting a list of numbers and you want to remove the duplicate, what you can do is you can convert it into a set, okay, and then convert back to list. Then all the duplicate elements in the list would have been removed. So you can do some conversions, very straightforward, very easy to do that, but it allows you to remove duplicate elements because sets themselves are having non-duplicate members. performing standard math set operations like what I showed you on sets such as union, intersection, difference, symmetric difference, etc. So sets do not support indexing, as I mentioned indexing, slicing, or other sequence-like operations. It doesn't allow any of this, because if indexing is not allowed, you cannot do a slicing on it. Okay, you cannot say that I want it from to set of, in an increment of step. This is start, end, and step. So I cannot do this slicing on sets. Sets do not allow mutable elements such as lists or dictionaries or tuples with mutable objects. So a tuple should have only immutable object. Lists themselves are immutable, so they are not eligible candidates for having them inside a set. Sets themselves are mutable, but it can have only immutable elements. I am just telling this, such as basic types int, float, strings, and tuples with immutable objects. Okay, I am just summarizing it. It is though it is mentioned here. Any questions so far on this? Okay.
Sir,
Yeah, go ahead.
sir, I have a question like as you already talked. So the syntax for creating the sets and dictionary. So how to differentiate Python Maven? It is a set or it is a dictionary?
Okay, I will anyway show you the code. We will see that. Okay. Even I would say that differentiating between whether you are passing a parameter or are you constructing a tuple, that is also a confusion is there. Bracket, parenthesis, inside them there are some elements separated by commas. Similarly, a flower bracket with the element. Now suppose I'll tell you a dictionary. So the confusion will come only how to differentiate between whether it is a dictionary or a set. So because both are having flower bracket. Now, how do you know if the objects are like this? It is a set. It can't be a dictionary, because dictionary need to have a key value pair. They are not. There is no key value there. Whereas K1 V1 K2 colon V2. Okay, I put a comma, so let me complete it. So this is a dictionary. Okay, so based on what you fill in, the compiler can easily identify whether you are constructing a set or a dictionary, because you are not going to define any type here and then a variable my dictionary, something like that. You are not going to do. So there is no type. You are going to give a label. So internally it has to know what type of object it is creating. So that's compiler needs to be aware what you are trying to do. Okay, it's not going to look at your variable name and then find out, okay, you are constructing a dictionary or a set, because I said my set, then it is a set only. So it is not going to look at the value. I can say my dictionary and then assign a set. Nobody is going to catch me. Only the person who is maintaining my code will certainly curse me, or he will search and then come to my house and kick me also if I say my set and then assign a dictionary to it. So compiler needs to know what you are doing and what you are assigning. So the object what it is creating, what type it is after it is created, or while it is creating, sorry. So it is I hope you are able to understand what I am saying. This will tell the difference between whether dictionary or a set. Is it clear?
Yes, sir.
Okay, thank you. Any other questions from anyone? Immutable, mutable, all that little bit I am saying that. Okay, don't worry. All that will become clear when you see the implementation. We will spend maybe two classes on this. This I have covered. Now sets basic operations. These are all length you have to apply on it so that you can find out the number of elements in them. you can iterate over it. Okay, you cannot index. When I say, see, there is another difference between, I said that indexing is not allowed on a set. I also said slicing is not allowed, right? Colon this, it's not there. But that doesn't mean that I cannot iterate. Okay, they are different. Only thing is, when I say indexing, I cannot say I want a 0th element, I want the first element. I can't say to get it from there. But I can say that I want one element from there, get me one element. It is like I show you a bag and then full of chocolates, maybe different types. You put your hand and pick it up. You cannot say that which chocolate I put it first in the bag. So you just take it out, whatever you get it, you get it. So similarly, when I say X in S, I get something, but that what I get need not be the items, the order in which I put it inside. Okay, remember that it need not be the order in which I put it inside. Similarly, if I have a set, okay, some elements are there, I iterate over it. Okay, now I add some element, suppose, okay, I add something to the set. Okay, some more element I add. Now again I iterate. The order in which those items came, they will be different. Okay, now it could the new element what you have added could enter into anything anywhere in between, and what you get as a first or a second, third, fourth element, there is no order maintained. Okay, it depends on the way it is implemented and the way keys are computed and how it is indexed into the set. So you may iterate it over, but you cannot expect some ordering the way you take out items from there. So you cannot have any dependency on saying that, okay, I iterated over the set last time, I got this as a first element, now I have added more elements into the set, now the first element what I get will be the same as what was given earlier, or what I got earlier. You cannot have an assumption. So you need to always keep in mind, when you are iterating over, you don't maintain any order in which those items are going to come. But you will get it. You can find out whether an element is there or not. You can find out membership. You can find out not there. You can find out. You can iterate over, no problem. And then is subset, superset, union, intersection, all the set operations you can do. I mentioned that there are operators also, so I can give it as a home exercise that you can try it out, or we can do it ourselves. We will do it in 2 classes maybe. I'm going to do this today, maybe sometime we will do this, so that we know both how to use them. Okay, so let us not go very fast. I want to make sure that whatever I tell you, you get it into the head. My aim is not to rush through. Please tell me if I am rushing through. At the same time, I should not be boring you also. So I need to really have a balance between them. So please feel free to tell me, sir, you are going very fast, slow down. Or tell me that you are too slow, please go fast. We are getting sleep. You may get sleep even whether I am going fast or slow, but still, I should not be inducing sleep to you, hopefully. Okay, so you can understand what they mean. Copy, I mentioned about deep copy and then shallow copy. So you need to have a different function, which is deep copy is there. Okay, that also we may see. Deep copy does every element it creates again and then copies it, so that if you modify something, it will not be affecting it. Okay, shallow copy, if you want to add something, or you can have a shallow copy or deep copy, whatever you want. Okay, now what are the other operations apart from something which you have seen? Okay, there is a pop, the push and pop stack operations. This pop, there is no particular element which will come, random element will come out. Okay, so it doesn't guarantee you that if I created a set with adding element one after the other, when I pop, I will not get the first element, or there is no guarantee that I will get the last element. I may get any element that I have added. Okay, random. It is purely random. It's not purely random. It's not that every time when you do pop, you are going to get a different items. As long as the number of the individual elements are the same, every iteration when you do, if you run it again and again, the pop will give you the same value. But don't get confused. Okay, what I'm trying to tell you is, when I say random, do not use it as a random seed. Okay, it's not like a random seed. Random seed really gives you, if random value, random function, if you are seeding it with a different value, it really gives a pure random value. Here it says random, that means do not assume it to be a random number. You cannot use a set for a random number generation, neither. But it is purely random in the sense you don't know in which order an object, when you add into a set, will get added. Okay, in which order it would have got added, and when you run a pop function on that, which element you will get is also not guaranteed, because I'll tell you, because it is dependent on the hash function, and that hash function, this computation is based on the content of the object, what it is pointing. Okay, you remember, always that they're all references. Okay, all of them are references, none of them are anything other than reference, an object pointing to some object. So if a hash function is computed, it needs to look at the content. Okay, you cannot go by the ID of this addresses and then come up with the hash function. Hash function really scans through your every object, and then whatever the content, it could be a list, or it could be a string, or it could be a floating point number, or it could be a tuple with immutable objects. Then it will go through all the contents so that they are all constant, they are not going to modify, they are not going to be changing. We are not passing a list which is going to be changing. So it will compute a hash function, which is a collection of the effect of all the contents of those objects. So you are going to get the different element will get different hash functions. So when you add a new element, the hash function may be different, and that index, index is based on the hash function output, right? So you may have a order getting modified when you are adding an element or removing an element. That's why I said pop does not give you exactly the same element. Okay, so it will give out something which is random in a sense. So clear removes all the elements from a set. So that means it makes an empty set. Clear makes an empty set and then gives you. Update adds multiple elements to the set of by union of itself. Okay, so I will talk about this with an example, how these two are different. Okay, add and update are different. We will see with an example rather than going through it, but let me explain. Here you add an element. Suppose if you are adding a string, okay, as a single entity into a set, okay, then you use an add function. Update, what does it do? Update function, if I give a string to it, it unpacks it. So it goes, every element it takes it out and then puts it into the set. Okay, so adds multiple elements to the set by union of itself with others. Now you see here, union of itself with others. So let me explain what this particular sentence means, the whole sentence. Okay, why should it give a union? Okay, why should it give union? Now suppose you have a set. Yes, let me call it as S1. Let me call 1, 2, 3. Now S1 update. Okay, I am feeding maybe a string 2, 3, 4. Now it unpacks it. That means it takes 2, it takes 3, it takes 4. Already S1 is having 1, 2, 3. So when it takes out 2 from this string, what you gave, adds multiple elements. So each element it takes out to the set, which set S1, by union of itself. That means union of S1 with the others. So it performs a union operation. Then what happens when it performs a union operation with this, it will get the same set, okay? Because union is already there, duplicate elements are not allowed. So 1, 2, 3 will not get another 2. Similarly, when it tries to do a union operation with S1, it gets the same set. So 1, 2, 3. 3 is also not going to get added. Now when it gets 4, union operation will get in 2, 3, 1, 2, 3, 4. So whenever you are adding an element or any set of objects, either you use add or update, it will verify that that particular object is not a duplicate in the set. So that it takes care. These libraries will take care. Now, okay, when you are using add and update, you are taking care of it. But what if, suppose if I have S1 equal to, I say 1, 2, 3, 4, 3, 4. Okay, if I say this, what I get finally added is 1, 2, 3, 4. So this duplicate element, it is not going to give you an error or say that, oh, no, you are giving me a duplicate element. It will not give you any error, but it will quietly remove the multiple copies in them and then gives you this. So that's why I said you can use a set function to remove duplicate elements. Suppose if you have a list with 1, 2, 3, 4, 3, 3, 1, 2, 3, 3, then if you form a set and then you transfer it to list, then what you get will be 1, 2, 3. So if you go through this transition, you are removing the element which are duplicate, because list doesn't bother about duplicate. But remember, when you are going through this, you are going to disturb the order. Okay, that you need to keep in mind, because set is not going to preserve the order. So whatever element you get out of it, it may not be in the same order that you have given. So that you need to keep in mind. But you can remove the duplicate elements from the list. Okay, fine. Now let me talk about hashing. I don't know whether I'll have time for showing you the example. It doesn't matter. We can run through the example in the next class also. Okay, I don't want to rush through, as I mentioned. So let me see if there are any questions before I go into hashing. Anybody wants to come online? Okay, fine. Now let me explain hashing. See, why do we need a hash? You might have used the hash in your algorithms, the courses. You need a hash when you have more number of elements. Okay, dictionary is one place where normal dictionary, what you have, the number of words in the dictionaries are going to be huge in number. Okay, so when you want to index them, you need to, suppose if you are having a total number of possible elements that you can get in a set, if you know that there are 10,000 elements which are expected to be in a set. Okay, set is used for set, or a dictionary is used for huge number of items, but it is implicit that not all the elements will be there in a particular time, but you may keep adding and deleting, removing, all that. So if you use indexed way of addressing it, you need to have the array of, suppose 10,000 elements you expect this dictionary to have. You need to have an array of indexes. They may be null. Okay, maybe some of them do not have an element right now, but you need to have an element, entry made for it. Okay, because you don't know when an element falling in this particular index might come into the get added to the dictionary or a set. So what happens is you will be wasting the space of maintaining a huge array of pointers, because it has to point to the object, right? So every object, if it is corresponding to a particular index, then I need to have a location, an array of pointers. Maybe initially it is filled with null, but later on when an element with this particular index is added, I may have the object, real object getting added to it. So it's a waste of space when you are maintaining such things. Okay, so direct addressing, this is called a direct addressing. Size of universe is huge, then your size of table should also be that much. When you When I say universe means universe is this whole set. You may have this, any element can be in A or in any element can be B. So you need to have a huge table. The size of table will be equal to the size of the universe, number of elements that you can possibly have. Impractical when it is very large. So now if you have a hash, you use the key, which are the actual keys or the element values, and then you compute the hash function, okay, which will be still again distributed. It will not be same. Sometimes the cache keys will be same, then you may have a clash there, but it is supposed to be distributed equally. Then what happens, the advantage is that you don't need to scan through it, okay. If it is a huge array, in terms of memory, suppose if you are a limited main memory you have and the huge array is in the hard disk, you may have to get the even this array indexed array into it and then process it. That kind of things will be there. But hash functions, when you use, you will be restricting to some list of values, and then it can expand it based on the type of element you add. It will keep expanding, and you choose the hash function in such a way that they are only m to m elements, okay. Though the number of possible elements are more, your indexing is within this limit, because hash function is limited to give you an index which is within this limit. Then you are restricting it the total size to only n element. So that is an advantage of saving space using the hash function. So key will be within this m-1 or m element. Index, the hash function generates an index into the table, which in turn points to the object which which is what it is. Now real content of that, okay. Remember, the key is different from the actual content of the object, because the actual content, based on that, keys are generated. So you may have a collision here. So the hash function reduces the range of array indices and hence the size of the array, and is very large. M is not, okay. The size of the universe is very large, but M is not. Search time is order 1 if there is no collision in searching with the HK. So if there are no collisions, you can search it in order 1, okay. The ordering is, the complexity is order 1. It doesn't increase based on the number of elements. Simple uniform hashing is achieved. Uniform hashing is achieved so that you can avoid collision. It is always finding some empty slots by choosing h of k such that the set of keys to be stored among the m slots are distributed equally. So if you want to store m keys, it is distributed equally, so you don't tend to have a collision in the key, okay. So thus reducing the collision. Now how do you search in the sets or a dictionary? Now please remember, the hashing is used in sets as well as in the dictionary, okay. A dot val, okay, comma b dot whatever, so colon c. So this is to access the key, you will be using the hash in the dictionary, and then once you find that index, it will be pointing to the value which is there, okay. So you will be searching for a key in the dictionary, and then once you find it, using the hash function, you go to the index and then access the value that is paired with this key, okay. That is how dictionary is accessed. Since elements in a set are to be hashable, only immutable objects are allowed, as I mentioned it. Hashing means using some function or an algorithm to map object data. As I told you, object data is used for computing the index by the hash function to some representative integer value, which is an index into a table. So that is a function, that is job of a hash function. The hash code, or simply hash, the implementation, can then be used as a way to narrow down the search when looking for an item in a collision, okay. So what you do is you do a hash and then you try to find out once within the thing, you can always find out the individual element. Okay, when looking for an item in a collection, you can find out based on the hash function. So in a collection, if you are looking for a particular element, you compute the hash, go to the index, then you are accessing the object. The hashing and the hash values need to have the following properties. Now, what are the properties of hashing and the hash values? Hash value is what you get from the hashing function. They need to be deterministic. That means whenever you pass the same object with the same content, it will return the same index, which is indexed into a hash table. Same message or key or data should result in a same hash. Sometimes hash value is referred as a hash. And then it should not be too complex. It should be some XOR operation or some binary arithmetic operation, so that it is how much time? Okay, it is not too complex to compute it. And then infeasible. To generate a key from a hash, it should be in such a way that you will not be able to get the key from the hash. Okay, it is for the safety purpose sometimes to avoid backtracking it. So you cannot nobody should know what hash function you are using internally. Infeasible, to find two different messages that yield to the same hash value. So you want to avoid the collision, because then order of one is not guaranteed, and then how will you resolve once the collision happens? So you should be possible to have whatever is implemented in this Python. It tries to make sure that there are no two different messages that yield the same hash value. Okay, you should not, two different messages should not give you the same hash value. At the same time, same message should always give you deterministic. It should give you the same value. See, remember, you may be wondering, how does the set know whether a particular element is there or not? So when you are passing set, already you have a set with the ABC, okay, and then you are saying that add A. Now it is going to compute the hash function. Okay, it is going to give, hash function is going to be passing this, A is going to be passed to it, and then this index is going to be used here. And if index is null, that means that element is not there. If it is already pointing to some object or it is filled, that means this object is already there. Then it will say that there is a collision or it's a duplicate function. That means what? Every time when you compute the hash function for a given object, it should always result in a same hash function. So it is deterministic. Similarly, if this A is resulting in a hash table entry here, when I pass a C, another function, another object, I should not get the same thing. There shouldn't be any collision. It should give me a different thing. If there is no C in the set, it should give me an empty place where I can put it. So it should be deterministic, as well as it should be infeasible to generate the same hash for a given message. Hash collision should be avoided. Similarly, a small change to a message should change a hash so extensively. That means you should, then only you can have a uniquely uncorrelated distributed keys, so that you don't get into a collision always, and you are managing the hash table properly. Okay, so what is hash function in Python? It's a fixed size integer which is coming out. Hash function generates hash based on the contents of the immutable object. I told you each element is added into a set by indexing into a hash table with a hash. When an element needs to be searched for it, hash is computed again for that object, and it is located within the hash table. Okay, searching for a hash is much faster, order 1, compared to searching for a huge searching for an object within a set, because they are expected to be huge. So, compared to searching for an object, computing hash function and then going to the table is much faster than looking into every entry in the table and then looking for whether this object is there or not. You have to go make an object comparison for that, which is very expensive. So set allows only immutable objects to be there, because hash will change if mutable objects are allowed to change. Reinserting the object whenever they change is an expensive operation. Okay, so you cannot if you are changing the object, then you need to remove it from the hash table and then compute the hash table hash function again and then add it. That's why immutable objects are only allowed within a set. And then a small change should distributed equally so that it doesn't have a collision. Who implements the hashlib module of Python implements it. Okay, so I have explained the hash now. We will not see the code today. We will see it in the next class. Okay, I think I am coming to the end of a class, so we will have a lab. Okay, anyway, I don't have to rush through still, but still I am supposed to give you gap. Okay, any questions, guys? So what I plan to do in the lab today, I will give you the list problem. They will maybe, if you want the solution, you want me to go through the solution that the problems that I gave you in session 5, I can do that. What I have implemented, I have seen that many of you have implemented and given. So it looks like all of you have done it, understood it. If it is not needed, we will not look at the solution. So I will give you a couple of problems, couple of more problems. Okay, not very complex, but I want you to use recursive method to implement it. Okay, that let us see. If you want, I will show you my solution, or you can solve and then give it to me. We can open another entry for it so that I can get the recursive implementation of yours before I influence you with my implementation. Then we can look at the solution. So since you have already submitted the session 5 solution, so I will show you my solution, and we can follow the same methodology for recursion also, whatever we are doing today. So whatever we do in the lab, maybe I will ask you to submit it so that we can keep you are forced to write those code and then become ready for the exam. And programming is not possible unless you practice yourself. So let us do that. Okay, any other suggestion? I am open to any suggestions. Please let me know. Any questions before we break? I hope whatever I explained today is clear, or whatever in the class. We will look at the sets tomorrow by implementing, showing the code, and then implementation we will see. Okay, no questions, then bye bye. See you at 8 p.m.